Hello, my dear students in grade 9. I hope you are all good. And I wish all these hard times we are passing through ends quickly to see you all soon. We have a new mathematics lecture this week, and as you can see, this is not a new lesson. We have seen this lesson last year in grade 9. I will be repeating the rules with you again. And of course, there are new rules in this lesson to learn this year. So the title of our lesson is Square Roots. Whenever we talk about square roots, we directly remember this symbol. This symbol is called the radical symbol, and the number inside it is called the radicand number. What are the objectives of our lesson? Number one, again, we will define a square root. Number two, find the square roots of a perfect square. Then number three, find the square roots of a non-perfect square. Number four, perform calculations with the square roots. The two calculations in this week will be addition and subtraction of square roots. Objective number one, define a square root. As a reminder, whenever we talk about the square of any number, the square of any number is a number written with a power 2, and its answer is always positive. So the square of any number, whatever the number is, a positive number or a negative number, to get its square, the answer is always positive. Let me give you examples. 4 squared is 4 times 4, which is 16. 7 squared is 7 times 7, the answer is 49. Minus 3 squared, the answer is, this is a negative base. So minus 3 is a negative base. Whenever the exponent is even, 2 is even, so the negative becomes positive, and we get the answer of 3 squared. 3 squared is 3 times 3, so its answer is 9. Minus 6, all of it squared. Also, this is a negative base. The exponent is even, so my answer becomes positive. And 6 squared is 6 times 6, which is 36. So, A, being a positive number, there exists a number whose square is A. Always, there is an A square. This number is called the square root of A, and it's written as radical A. We have 3 rules here. We have radical A squared. How do we simplify this? Since the number inside has a power 2 or an exponent 2, we say the square cancels the radical, and my answer is A, where A is positive. Radical A, all of it squared, also the squared cancels the radical, and my answer is A. Radical minus A, all of it squared, this is a negative base and the exponent is even, so the number becomes positive and the square cancels the radical. My answer is A. Let's look at this radical A. As I said, the symbol is called the radical, and the number inside, which is A, is called the radicand. Let's solve an exercise. Let's simplify radical 6 squared. So the number inside has an exponent 2, and it's positive. So the 2, the squared, cancels the radical, and it gets out as 6. Radical 11 squared, also, the number inside has a square exponent, so the square cancels the radical, and it comes out as 11. Radical 4 squared, also the squared cancels the radical, and my answer is 4. Now, radical 2, all of it squared, is the squared cancels the radical. My answer is 2. Radical negative 5 squared, let me take this up here. So radical negative 5 squared, this is a negative base, the exponent is even, so it becomes positive, and the squared cancels the radical, so my answer is 5. Radical negative 13 squared, also it becomes positive since a negative base and exponent even, so the squared cancels the radical. My answer is 13. Radical 7, all of it squared, also the squared cancels the radical, so my answer is 7. Please practice this exercise on a draft. We have important rules. Always radical 0 gives me 0. It has only one square root. Radical 1 is equal to 1. A radical negative a, when the radicand inside is negative, this radical does not exist. For example, radical negative 5 does not exist. Radical minus 9, a negative. Radical minus 13 is negative. Radical minus 16, this is negative. Radical minus 5 squared, this is not a negative base. Why? Because we do not have parentheses squared. This square is only for the 5. It has nothing to do with the negative. So my answer inside will be negative 25. So all these radicals does not exist. Minus radical a squared. Now the minus is outside. So I leave it outside and I say the square cancels the radical. So my answer is minus a. Minus radical 5 squared. I keep the minus outside. The squared cancels the radical. So it becomes minus 5. Also, the minus stays outside, the square cancels the radical, so my answer is negative 7. Let's find the square roots of a perfect square. What do we mean by perfect squares? Also, these we studied last year. We have numbers that are perfect squares. 1 equal 1 squared. We can write it as a number squared. 4 can be written as 2 squared. 9 can be written as 3 squared. 16 can be written as 4 squared. 25 is 5 squared, etc. Please memorize these perfect squares well. Always the square root of a perfect square, the square cancels the radical, and my answer is A. Let me solve an exercise. Radical 5 squared, this is written as a number squared. So the rule says the square cancels the radical. My answer is 5. Radical 11 squared, the square cancels the radical. So my answer is 11. Now radical 36. Is 36 a perfect square? Yes. 36 is the perfect square as 6 square. So I write it radical 6 square. Now the square cancels the radical. So my answer is 6. Radical 9. Is 9 a perfect square? Yes, it is a 3 squared. So I write it radical 3 squared. Now the squared cancels the radical. My answer is a 3. Radical 100. Is 100 a perfect squared? Yes, it's written as 10 squared. So radical 10 squared, the squared cancels the radical, and my answer is 10. Now radical 1, we can write it as a perfect squared, radical 1 squared. The squared cancels the radical, so my answer is 1. Now, how can we find the square roots of a non-perfect square number? I ask myself, can we find the square root of a non-perfect square number? Of course, yes. How can we do this? If the number given inside the radical cannot be written as a perfect square, what we do is we decompose the given number into prime factors using prime factorization method. You remember the prime factorization method. So as an example, I'm given radical 18. I ask, is 18 written, can we write it as a perfect square? No. So we should decompose it into prime factors. We draw a vertical line and we do the prime factorization. This is the prime factorization of 18. So it's 2 times 3 times 3. Now I write here the prime factors of 18. It's written, as you all know, 2 times. Because we have 3 2 times, we write it 2 times 3 squared. These are the prime factors of 18. Now, these prime factors, we replace them inside the radical of 18. So instead of 18, I write radical 2 times 3 squared. Now, does 2 have an exponent square? No, so I leave it inside the radical. Does 3 has an exponent square? Yes. So it comes outside the radical as a 3. So my answer is 3 radical 2. Another example, radical 24. Is 24, can we write it as a perfect square? No. So we make the prime factorization, and here I write down in the box the prime factors of 24. As you can see, we have 2 3 times, but we do not write it 2 cubed. We write 2 squared times 2 times 3. So these are the prime factors of 24. Now we replace the prime factors of 24 inside the radical. So now I ask, 2 squared, because it has an exponent 2, it comes outside the radical as 2. And we leave inside the radical 2 times 3 since they do not have exponent 2. So my answer will be 2 times 2 radical 2 times 3 equal 2 radical 6. Practice also these exercises. And here on this slide, you have 2 more exercises solved for you. Now, if you have radical a to the power 4, if the exponent of any number is 4, 4 is more than the exponent 2 that I need inside. 4, since it's an even number, I ask, which number I multiply it by 2 to give me 4? It's 2. So here I write the exponent 4 as a power of power. A to the power 2 times 2, 2 to the power 2. Now this square cancels the radical and it comes out as a squared. Radical a to the power 6, how can I simplify it? 6 can be written as a 3 times 2. So I write it a cube, all of it to the power 2. Now the squared cancels the radical and it comes out as a cube. Radical a cube, these are even exponents, so I make them a number times 2, a number times 2. Now 3 is an odd exponent. I make it 2 plus a number. So 3 is 2 plus 1, gives me an exponent 3. Now this comes out as a, so the answer is a radical a. Also practice these exercises on a draft. When you have an even exponent, you make it as a power of power and always the exponent 2 outside to cancel it with the radical. And whenever you have an odd exponent, you make it as even plus 1. For example, 3 is 2 plus 1, 7 is 6 plus 1, 9 is 8 plus 1, and etc. Now, we will perform calculations with the square root. The 2 calculations of this week are addition and subtraction. We will learn together how we can add or subtract square roots. The rule is very important for you to memorize. We can add or subtract similar or like radicands only. So whenever you are adding or subtracting radicals, you look inside at the radicand. The radicals should have the same radicand. How do we do the addition or the subtraction? Now, this is the rule. We add or subtract coefficients and we keep the radicand as it is. What do we mean by the coefficient? The coefficient is the number in front of the radical. Here the coefficient is 5, here the coefficient is 6, here the radicand is 2, and here the radicand is 2. So 5 and 6 are called the coefficients, 2 is called the radicand. So I have addition of 2 radicals. I look at the radicand here, it's 2. The radicand here, it's 2. Since they are similar or like radicands, I can add now the coefficients. I say 5 plus 6 is 11, and I keep the radicand as it is, so my answer is 11 radical 2. Now the second example, which is the one down. Minus 11 radical 3 plus 8 radical 3. Here I have radical 3, I'm adding it with another radical 3. Since I have same radicands, I can add or subtract the coefficients. On your calculator, minus 11 plus 8 is minus 3, and I keep the radical 3, so my answer is minus 3 radical 3. Now, minus 4 radical 5, minus 3 radical 5. These are like radicands since I have the same radical inside, so I can subtract them. Minus 4 minus 3, on your calculator, it gives you minus 7, and I keep radical 5 as it is. 13 radical 7 minus 8 radical 7. I have same radicands, which is radical 7. So 13 minus 8 is 5. So I keep it 5 radical 7. Now 6 radical 2 plus 8 radical 5. Here the radicand is 2. Here the radicand is 5. Since they are different radicands, So the radicands are different. We cannot add different radicands. So my answer will be written as 6 radical 2 plus 8 radical 5. Let me give you an example. Suppose this is 6 apples plus 8 bananas. Does it give me 14 apples or 14 bananas? Of course, no, since they are different things. So they are kept as they are. We cannot add different radicands together. This is very important. Now, minus 5 radical 11 minus 2. This is a radical and this is a number. They are different from each other, so we cannot subtract them. So since they are different, so they are kept as they are. Now, minus 3 radical 5 plus 2 radical 2 minus 5 radical 5. Here the radicand is 5, here the radicand is 2. They are different, we cannot add or subtract them. Here the radicand is 5 and minus 5 radical 5, the radicand is 5. So we can add or subtract both of these. Now the coefficient minus 3 plus the coefficient minus 5 gives me minus 8 radical 5 and 2 radical 2, I keep it as it is. Please practice these exercises are very, very important whenever you are watching the video on draft. Now, sometimes to add and subtract radicands, we should simplify them using prime factorization. Let's look at this expression. 4 radical 8 plus 7 radical 18 minus radical 32. Here the radicand is 8, here the radicand is 18, and this radicand is 32. All of them are different. We cannot add or subtract them, but 8 is not a prime number. I should change it to a prime number using prime factorization. Also 18 should be written as a prime number using prime factorization, also 32. So here I should make 3 prime factorizations for 8, 18, and 32. This is the prime factorization of 8. This is the prime factorization of 18, and this is the prime factorization of 32. Now I replace the prime factors of 8 under the radical 8. I replace the prime factors 18 under the radical 18, and I replace the prime factors of 32 under radical 32. So this is how I replaced. Now I simplify each radical. 2 squared comes out as 2. Since I have 4 outside, when 2 comes out, it's multiplied by 4. Here, 2 is kept inside since it has no square. 3 squared will comes out as 3, so I write 7 times 3. Here, 2 squared comes out as 2, and the other 2 squared comes out as 2, so they are written as 2 times 2, and I keep the 2 inside, so this is my answer. Now I multiply these coefficients. 4 times 2 is 8 radical 2. 7 times 3, 21 radical 2. 2 times 2 is 4 radical 2. Now, as you can see, all the radicands are similar. Now I can add or subtract the coefficients. On my calculator, 8 plus 21 is 29. Minus 4, it becomes 25. So my answer is 25 radical 2. Also practice this exercise on a draft. This was our lecture for this week. Please watch the video well, and if you have any question, contact me directly. I will answer all your concerns. Bye. Love you.